You would explode in space. If you've watched enough sci-fi, you know the scene. An airlock opens, a character is sucked out, and within seconds they swell up and pop like a balloon. It's a terrifying image, but it's actually a total lie. In reality, your body is much tougher than Hollywood gives it credit for. You wouldn't explode for a very simple reason. Your skin. Human skin is incredibly strong and elastic. It acts like a natural pressurized suit, holding your insides together even when there's zero pressure outside. You wouldn't even freeze instantly, because space is a vacuum. There's no air to pull the heat away from your body, so you'd actually stay warm for quite a while. The real danger is much quieter. In a vacuum, the boiling point of liquids drops. This leads to something called ebullition. The water in your eyes, mouth, and soft tissues would start to vaporize, causing your body to swell to nearly twice its normal size. You'd look like a bloated, inflated version of yourself, but you wouldn't pop. The biggest mistake you could make is trying to hold your breath. Without external pressure, the air in your lungs would expand violently, rupturing the delicate tissue like an overfilled tire. Instead of an explosion, you'd have about 15 seconds of consciousness before your brain ran out of oxygen. You wouldn't be a human bomb. You'd just be a very swollen, very quiet traveler drifting into the dark. Mercury is the hottest planet. This is one of those logic traps that seems so obvious until you actually look at the data. If you're standing next to a campfire, the closer you get, the hotter it feels, right? Since Mercury is the literal front row seat to the sun, everyone assumes it's a scorched, molten wasteland 24/7. But that's the big lie. Mercury is actually a world of extremes that would kill you in two different ways. Because it has almost no atmosphere to trap heat, it works like a broken thermos. During the day, it hits a blistering 430 degrees Celsius. But the moment the sun sets, all that heat just leaks straight back into the void. At night, the temperature crashes to a bone-chilling minus 180 degrees Celsius. It's the only place in the solar system where you could get a lethal sunburn and freeze to death at the exact same time. The real oven of the solar system is actually Venus, the second planet from the sun. Even though it's twice as far away as Mercury, Venus is wrapped in a suffocatingly thick atmosphere of carbon dioxide. This creates a runaway greenhouse effect that traps heat like a locked car in the summer. While Mercury is busy cooling off at night, Venus stays at a constant, hellish 465 degrees Celsius everywhere, all the time, even at its poles and in total darkness. It's hot enough to melt lead and high pressure enough to crush a submarine. Mercury might be the closest, but Venus is the true heavyweight champion of heat. The dark side of the moon. This is one of the most persistent myths in history, mostly because the name sounds so mysterious. We've been taught there's a dark side of the moon, a place of eternal shadow where the sun never shines, hiding secrets in the blackness. Even Pink Floyd named one of the greatest albums of all time after it. But in reality, the dark side doesn't actually exist. The confusion comes from a phenomenon called tidal locking. Because the moon rotates on its axis at the exact same speed it orbits Earth, it always shows us the same face. We only ever see about 59% of the lunar surface from our backyards. The other 41% is the far side, and that's where the dark lie begins. Just because we can't see the far side doesn't mean it's dark. The moon experiences days just like Earth. They just last about 2 weeks. When we see a new moon from Earth, when our side is pitch black, the far side is actually bathed in full, brilliant sunlight. There is no part of the moon that is permanently dark. Every square inch gets scorched by the sun eventually. What makes the far side truly dark isn't a lack of light, but a lack of communication. The massive body of the moon blocks all radio signals from Earth. If you were standing back there, you'd be in the most silent place in the solar system, completely cut off from every phone call, TV broadcast, and internet ping on our planet. It's not a world of shadows, it's a world of total eerie isolation. Saturn is the only planet with rings. This is probably the most successful lie in our solar system, because Saturn is such a show-off. When you think of a planet with rings, those massive shimmering bands of ice and rock are the first thing that come to mind. They're so bright and iconic that for centuries we were taught that Saturn was the Lord of the Rings, a unique crown jewel in a solar system of otherwise naked planets. But the reality is that rings aren't a rare luxury. They're actually a standard feature for the giants. Every single one of the outer gas planets like Jupiter, Saturn, Uranus, and Neptune has a ring system. The only reason we don't talk about the others is that they aren't made of highly reflective ice like Saturn's. Instead, they are made of dark, soot-like dust and organic compounds that barely reflect any light at all. Jupiter's rings are so thin and ghost-like that we didn't even know they existed until the Voyager 1 spacecraft literally flew behind the planet and saw them backlit by the sun. Uranus has at least 13 distinct rings, some of which are pitch black like charcoal. Neptune's rings are even stranger. They aren't even complete circles in some places, appearing as arcs or clumps of debris that look like they're still struggling to form. Saturn isn't the only planet with rings, it's just the only one with a clean set. While Saturn's rings are young and brilliant, the others are dark, ancient, and dusty, the shattered remains of moons that got too close and were ground into powder billions of years ago. The sun is a burning fire. When you look at the sun, it's easy to believe the lie. It looks like a giant, roaring campfire in the sky, a massive ball of golden flames flickering in the dark. We're taught from a young age that the sun burns, but if you could somehow bring a giant bucket of water to douse it, you'd actually make the sun hotter and more violent. That's because the sun isn't on fire at all. Fire is a chemical reaction that requires oxygen, but space is a vacuum with no oxygen to speak of. If the sun were actually burning like wood or coal, it would have run out of fuel and gone dark millions of years ago. Instead, the sun is powered by a process called nuclear fusion. Deep inside the sun's core, the pressure is so intense that it crushes hydrogen atoms together until they fuse into helium. This doesn't create flames. It releases a terrifying amount of pure energy and light. It's essentially a trillion hydrogen bombs detonating every single second. What we see as flickering flames on the surface are actually loops of superheated plasma, trapped and twisted by massive magnetic fields. The sun isn't a burning fire. It's a self-sustaining nuclear reactor held together by its own gravity. It doesn't need air to breathe. It just needs its own weight to keep crushing atoms. It's a clean, efficient, and incredibly violent engine that has been running for 5 billion years without a single spark of real fire. The asteroid belt is a minefield. If you've ever watched Star Wars, you know the scene. Han Solo weaves the Millennium Falcon through a dense thicket of tumbling rocks, pulling off impossible maneuvers to avoid a head-on collision. It's one of the most iconic images in cinema, and it's led us to believe the asteroid belt is a cluttered, high-speed minefield where you're always 1 second away from being crushed. But if you were actually flying through it, you'd probably be bored to tears. The asteroid belt, the massive gap between Mars and Jupiter, is home to millions of objects. Some are as small as pebbles, while others, like Ceres, are the size of Texas. But space is unimaginably big. The distance between the sun and the edge of the solar system is so vast that even with millions of asteroids, they are spread incredibly thin. On average, the distance between any two major asteroids is about 600,000 miles. That's more than twice the distance from the Earth to the Moon. If you were standing on one asteroid, you wouldn't see a field of rocks around you. The next nearest one would be a tiny, dim speck in the distance, barely visible to the naked eye. NASA has sent dozens of spacecraft through the belt, including the Voyager and Cassini probes, and they don't even have to plan dodging maneuvers. The odds of accidentally hitting an asteroid are about 1 in a billion. It's not a crowded obstacle course. It's a vast, lonely desert where the rocks are hundreds of thousands of miles apart. Hollywood's minefield is a lie. In reality, the asteroid belt is mostly just empty space. Earth is closer to the sun in summer. It feels like common sense. The closer you are to a heater, the warmer you feel. So, if it's summer and the sidewalk is melting, the Earth must be physically closer to the sun, right? This is probably the most widely believed lie in astronomy, but the truth is actually the complete opposite. During the Northern Hemisphere's summer in July, Earth is actually at its aphelion, the point in its orbit where it is farthest from the sun. We are roughly 3 million miles further away in July than we are in January. If distance were the only factor, we'd be freezing in the middle of July. The real reason for the seasons has nothing to do with distance and everything to do with tilt. Earth doesn't sit straight up and down, it leans at an angle of 23.5 degrees. During the summer, your hemisphere is tilted toward the sun. This doesn't just mean the sun is closer. It means the solar rays hit the ground at a direct, steep angle, concentrating all that energy into a smaller area. Think of it like a flashlight. If you shine it straight down, the spot is bright and hot. If you tilt it, the light spreads out and gets weaker. In the winter, we are actually physically closer to the sun, but because we are tilted away, the sunlight hits us at a shallow, weak angle, and the days are shorter. The The summer distance is a myth. It's the leaning of our planet that actually brings the heat. That's it for today. Subscribe for more, smash the like button, and drop a comment with your thoughts. I read every single one. Peace.